Um, Hello. Today I'm going to be covering a topic, another important topic which is really important for calculus one, which is a differentiation or derivative. Derivative of a function, or that will help you actually when you when you want to calculate when you want to find the equation of a tangent line, all that. I will go by explaining first by reviewing some of the formula that you will have to be able to memorize, and for each formula I will do one example. Let's start. First of all, I want to talk about the product rule. It turns out that whenever you have a function g, whenever you have a function like this, f times g, and you want to take the derivative, the primate, take a derivative of that, is the same thing as doing a product rule, f prime g plus g prime f. That's the first step. Now let's do an example of this first rule. An example is, let's say they give me a function f of x is x tan x tangent x. My first thing to do at this point is to identify what is my f. As you can see, it's like a composite of two functions. F can be this one, and this one can be considered g dx. That means, first of all, your first step to do is to take the derivative of that, of x. Derivative of x is what? 1. That means it's going to be 1 times what? G, which is my 10x. You can see that. Plus the derivative of this one, g prime. It turns out that 10x derivation of that is secant square x. That means it's going to be plus secant square x, but times f. My f was x. That means it's going to be like that. That means my final answer is 10 x plus x secant square x. As you can see, that will be your final answer. That means what? Whenever you have a function that is a product, you use a product rule, f from g plus g prime f. That's what you can do. Now let's move to another important rule of differentiation, which is the quotient rule. And I'll give another example. Whenever you have two functions like this, a function f over g, what we do is, according to the product rule, the derivation of that is f prime g, okay, minus g prime, the bottom, f, over g square. Now let's give an example that we can quickly manage a little bit here. Let me say that I have a function 2x over x square minus 1. They want me to derive that, to find the derivative of that. They want me to find the derivative of that. I mean, basically I will use the same rule that I was saying, the product rule. That means I'll take the derivative of 2x, which is the derivative of 2x is 2. I'm doing a 2 times the bottom. I'm not changing anything at the bottom. Minus the derivation of that. The derivation of x squared minus 1. You just take that. You don't consider that because this is going to give derivation of negative 1, 0. The derivation of x squared is going to give you 2x. That's going to give minus 2x times what? Times the derivation of times f. My f here in this case is 2x over the bottom square. Therefore, if I can erase it, you're going to see that your answer will be 2x squared minus 1 minus 4x squared over x squared minus 1 squared, as you can see. As you can see now. as you can see. Now, if I move a little bit, let me rewrite everything a little bit and erase and put things on top, and we can see a little bit in a better form. Now, when you have that, it's always going to give you 2x squared minus 1 minus 4x squared over x squared minus 1 squared. Now, if I want to, I can rearrange the bottom, the top a little bit to make it a little bit portable. I'm going to give you 2x squared minus 2 minus 4x squared over x squared minus 1 squared. This one give me 2 minus 4, give you negative 2x squared minus 2 over x squared minus 1 squared. What I can do, I can either leave it like that. Yeah, I can leave it like that, and that's it. That will be the derivation of that. That's the second rule that I just verified. Basically, that is what your answer will be. That the derivation of that function that I just showed you before, that is the answer. Now, let's move to the next critical method of derivation in calculus, which is the chain rules. The chain rule. What we do now? What does the chain rule says? It's like, for example, like I'm gonna apply it with the example. When you have a function, for example, let me say I have sinus 5x. What we do, we apply the chain rule. You derive, according to the chain rule, you derive the inner function times the outer function. Basically, it's like inner function times the outer function. For example, you have u times a function g. That means you do the inner, that's going to be your inner, and this is going to be your outer. Let me put it in a better way. Let's say that you have a function u of like u of 5x, two functions. This is considered as a function, and this is considered as a function, f and g. Okay. Now, what you do according to product rule, according to the chain rule, you do your inner. This is considered as your inner, and this is your outer function. What we do, derivation of that, of the whole thing, gonna give you the inner, derivation of the inner times the derivation of the outer. As you can see, I mean, I take the derivation of the inner times the derivation of the outer. Let me illustrate what I'm trying to say here. Let me see what I'm trying to say to you here. In a couple minutes, if I have sinus 5x, let me do sinus 5x, and I want to do the chain rules here. My inner function is 5x, my outer is sinus 5x. Therefore, I take the derivation of 5x first, which is going to give you 5. I want to find the derivation of that. And that means I take the derivation of my inner, that is my inner function. And this, the whole thing here, is my outer function. That means I take the derivation of that. Then I give you 5 inner, 5x, derivation of 5x is 5. Times the derivation of the whole thing. The derivation of sinus is what? Is cosine. That is going to give you cosine 5x. And that's all. That is what the chain rule is about. You derive the inner function times the derivation of the outer. And that is basically the three basic rules of that is going to be the main rule for derivation in calculus 1. Another video will come where I will do a lot of them, where I will explain it and go further. Thank you. Thank you.